In this lecture, we will go over the CFA Level 1 reading on fixed income valuation. Here are the topics we will cover: bond prices and time value of money. Here we will learn how to price a bond using time value of money concepts. Section 3 deals with conventions for quotes and calculations. Here we will look at the conventions for long-term bonds, money market instruments, and so on. Section 4 deals with the maturity structure of interest rates. Here we will talk about the spot rate curve, the yield curve, the par curve, and the forward curve. And finally, we will talk about yield spreads such as the Z spread and the option adjusted spread. Section 2, bond prices and the time value of money. This is a very important section. It has 4 subsections. 2.1, bond pricing with a market discount rate. What we are going to talk about here is the most basic way of valuing a fixed income security. The principle is this: the price of a bond is equal to the present value of all future cash flows at the market discount rate. And I've alluded to this before, and this concept has been covered earlier in quantitative methods and corporate finance. The basic idea is that you project the cash flows and then discount those cash flows back at a rate. That rate is called the market discount rate. It is the rate required by investors when they invest in a bond, and obviously that rate depends on the risk of the bond. If the bond is very risky, then the market discount rate will be high. If the bond is not so risky, then the market discount rate will be low. The market discount rate is also called the required yield or the required rate of return. Let us do an example from the curriculum. If we have a bond where the coupon rate is 4%, and for simplicity we'll say that the payment is made once a year. The time to maturity is 5 years and the market discount rate is 6%. What is the bond price per 100 of par value? First thing we should do is draw the cash flows. Time 0, 1, 2, 3, 4, 5. So since this is a 4% bond and we are taking a $100 par value, that means that at the end of every period the cash flow is 4. Last period the cash flow is 4 plus the par value of 100 is returned. The question now is, what is the present value at time 0? The present value represents the price of the bond. All we need to do here is discount back each of these cash flows at a rate of 6%, the market discount rate. The curriculum solves these problems by actually calculating the present values and adding up all these present values. But if you do this on the exam, it will take too long. So I want you to use the financial calculator. What you need to do is plug in the following. N is equal to 5. The interest rate is equal to 6%. Payment is equal to 4. Future value is equal to 100. And you compute the present value. The answer you should get is minus 91.575. I hope you remember this from quant, but when you plug in positive numbers for future value and payment, the calculator will give you a negative number for the present value. And this makes sense. You can think of the fact that this is the money that you will get. To get all this money, you need to make an investment. Investment means money out, which is depicted as a minus. Let's say we have another 5-year bond which has a coupon rate of 8%, again paid annually. If the market discount rate is still 6%, what is the price of the bond? You can do this very quickly. Notice that the rate paying by the issuer or the rate being received by the investor is higher than the discount rate. So in this particular case, again, n is equal to 5. The interest rate is equal to 6%. The payment now is going to be 8% of par value, which is 8. The future value is still the par value, which is 100, and you compute PV. The present value is minus 108.425. This is larger than the par value of 100. When we have a bond which is valued more than par value, then we say this is a premium bond. And the reason is investors are getting a coupon rate of 8%, but the riskiness associated with the bond says that the discount rate only needs to be 6%. So to get a rate of 6%, which is lower than 8%, the investors pay an amount which is higher than par value. What if the coupon rate is 6%? So we use all the same numbers except we say that payment is equal to 6. Here the present value will be 100, and this is called a par value bond because the coupon rate is the same as the market discount rate, and when that happens then the present value or the price is equal to par value. What if the coupon rate is 2%? Here you plug in payment equal to 2, all other numbers are the same, and when you compute present value, what you will get is 91.575, and this is called a discount bond. When the bond is selling at a price which is below par value, then we say we have a discount bond. The reason is that investors require a return of 6%, but the bond is only paying a coupon of 2%. So to get the higher return, investors pay an amount which is less than the par value of 100. So to summarize the points that we have talked about, when the coupon rate is less than the market discount rate, we have a discount bond. That's the scenario that we just talked about. When the coupon rate is greater than the market discount rate, which was the first situation, then we have a premium bond. And when the coupon rate and market rate are the same, then we have a par bond. Now I want you to do example 1 from the curriculum. Figuring out whether the bond is a discount bond or a premium bond or a par bond is easy. You just compare the coupon payment with the market discount rate. When the coupon payment is low relative to the market discount rate, then we have a discount bond. That is the case with bonds A and D. D in fact is a pure discount bond, which means that the coupon rate is 0 and the market discount rate is 2%. So A and D are discount bonds. C is a par bond because the coupon rate and the market rate are the same. And bond B is a premium bond because the coupon rate is high relative to the market discount rate. This question asks us to calculate based on equation 1, but what I want you to do is actually use the calculator because that's what you will do on the exam. You need to understand equation 1, which is simply discounting using the time value of money, but that's what the calculator is doing. So use the calculator. I will do this for bond A first. We have 6 periods, so n is equal to 6. The interest rate is 3, so you plug in I is equal to 3. Payment is based on the coupon payment, so that is equal to 2. The future value is 100 because we are doing this based on $100 par value, and then you compute PV. The deficiency that the question asks about is the par value 100 minus this number, which will give you 5.417. You can do the same for all the other bonds. With bond B, coupon rate 6 means that payment is 6, N is 4, interest rate is also 4, FV is 100. When you compute the present value, you should get 107.26. With bond C, coupon payment is 5, so payment is 5, N is 5, interest rate is 5. This is a par bond, so without any calculation, you know that the value of the bond is 100 and there is no deficiency. And finally, bond D, you can plug in payment is equal to 0. Number of periods N is 10, discount rate or the interest rate is 2, FV is 100, and when you compute the price, you should get 82.035. Section 2.2 deals with the concept of yield to maturity. The yield to maturity is the internal rate of return, or the IRR, and we've seen this in quant and in corporate finance. So the YTM is the internal rate of return on the cash flows. It is the uniform interest rate such that when the future cash flows are discounted at that rate, the sum of the present values equals the price of the bond. This is simply the definition of IRR. The rate then is the implied market discount rate. In the previous example, we were given the discount rate and we calculated the price. Here we are saying that the price is known and we compute the YTM. Let's do example 2 from the curriculum, and again I will encourage you to do this using the calculator because that's what you will do on the exam. As long as you understand the concept, that's what you really need. After that, use the calculator. So we have bond A, we are given the coupon payment, we are given the number of periods to maturity and the price. For bond A, I'll just show you the concept the way it is shown in the curriculum, and then we'll use the calculator. So what we are saying is that the bond price is 103.75. This is equal to the present value of the coupon payments and then the final par value. If we have 4 payments, the first payment is 3.5, so we'll discount 3.5 at a certain rate. Then we will discount the second 3.5 at 1 plus r squared, and then 3.5 over 1 plus r cubed, and then 103.5. This is the final par value plus the coupon discounted at 1 plus r to the power of 4. The rate which makes the left side of the equal to and the right side of the equal to equal is the IRR, and again that is just the definition of IRR. Now solving this manually will be nearly impossible, but you know it can be done, and we will do this using the calculator. Here is what you plug in. N is equal to 4. The interest rate, that's what we are actually going to find. The payment is equal to 3.5. The present value we are going to plug in as a negative number, minus 103.75. The future value is equal to 100. That is the par value at the end. And then we compute I. So do this on the calculator. What you will get for I is 2.50%. And this makes sense because clearly the bond is trading at a premium. When the bond is trading at a premium, we know that the coupon rate is higher than the implied market rate that we've calculated over here. You can use the same logic for bonds B and C. With bond B, what you should get is 2.89%. This is a discount bond, so the market rate is higher than the coupon rate. And bond C is clearly a discount bond. In fact, it is a pure discount bond or a zero coupon bond. And here the rate is going to be 2.53%. In doing the YTM calculations and coming up with the YTM number, we make three important assumptions. This is called yield to maturity. So we assume that the investor holds the bond till maturity. If the investor sells the bond before maturity at a premium or a discount, then the yield will be different from YTM. The second assumption is that the issuer makes all payments, coupon payments and the final par value payment in full and on time. And finally, we assume that the investor reinvests the coupon payments at the YTM rate. And this again is exactly what you saw with IRR. And let me make sure you understand what this means. If we take our first bond, bond A, then at the end of every period, the investor is getting 3.5. So at the end of period 1, he gets 3.5. At the end of period 2, he gets 3.5. The assumption is that all these coupon payments are being reinvested at the YTM rate. If interest rates change and the rates go up and this number is being invested at a higher rate, then the actual yield will be different from YTM.